Now, for the next several slides, we're going to look at 4 ratios that give us some metric for evaluating performance. These 4 ratios are called recall, precision, discrimination, and fallout. Before we break down the ratios, let's get on the same page about what we're really talking about. The ratios are meant to express how well the system did at retrieving documents that are relevant to a particular query. So it's not exactly correct to say that database A has 67% or database B has 94% precision. Each recall or precision calculation is made pertaining to a particular query, and it is entirely possible for a database to do better with some queries than others. Now, a database might take a whole bunch of recall ratios over different queries and average them together to get a sense of its overall performance on recall across queries, but that's different than a pure recall ratio, which we're talking about here. And another thing about how these tests work, all of the ratios are constructed by knowing, in a particular collection and for a particular query, how many items in the whole collection are relevant to that query, and by corollary, we know how many items are not relevant or irrelevant. We also know how many items in the whole collection were retrieved by the query, and by corollary, how many items in the collection were not retrieved. All of this means knowing before the fact, first of all, how many items are in a given collection or database, as in how many documents or surrogate records, basically how many information entities are represented in this collection. And by collection, I mean the content of a database. We also have to know before the fact, before the test, how many items are actually relevant to all of the queries that will be run as part of the test. Think about it. If I'm going to give you a test, I can't know whether you did a good job or not finding the square root of 25 unless I know the answer to that question myself. That means before the test is run, there has to be some knowledge or estimate of the relevance for test queries of all the documents in a collection, or more likely, a statistically sound sample of the collection will be drawn so that these handmade judgments can be made and compiled. Anyway, I don't want you to worry too much about understanding the sampling precisely, but I do want you to understand that these are not simple values to come up with. You'll get some hands-on practice with this activity later on. As you do the activity, think about extrapolating this process to a collection of 1 million or more documents rather than a few simple sentences, and you'll have an idea of how complex quantitative evaluation can be. Now, all of that said, let's talk through the first 2 ratios, recall and precision. Keep in mind that for any given query, a document in the collection might or might not be relevant to that query, and the same document might or might not be retrieved. Relevance is a human judgment, and retrieval is what an algorithm does. In the best case scenario, there's a perfect match so that an algorithm can make the exact same judgments that a human would, and an algorithm or search engine would, in every case, retrieve all relevant documents and only relevant documents. But that never happens. So with recall, we are looking at a ratio for a query. On the top of the ratio is the number of documents that are both relevant and retrieved. We ask, is the document relevant to the query? Then we ask, was the document retrieved by the query? If the answer to both questions is yes, the document is relevant retrieved. The bottom of the recall ratio says all relevant. So that's the number of documents in the entire collection that were relevant to the query, regardless of whether the algorithm retrieved the document. The recall number is telling us, of all relevant documents in the collection, how many were retrieved. Recall is calculated as a ratio, then it is converted to a decimal number. So if a given test found a recall ratio of 8 out of 10, we would say that the system scored a recall of 0.8 for that query, or 80%. Precision has the same numerator as recall, relevant retrieved, but its denominator is the number of documents that was retrieved by the query. Precision tells us of all the documents retrieved by the query, how many of those were relevant. When you need to make sure that you see each and every resource in a collection that's relevant to your query, you don't want to miss a thing, then recall is more important to you. And if you want to see a results set with very few irrelevant results, you don't want a lot of noise in your results, then precision is more important to you. And it turns out there is a natural trade-off between recall and precision, and we'll see that in the next slide. It's also important to point out that these measures are not measuring whether the search algorithm literally, it's important to point out that these things are measuring whether the algorithm did what it was told to do. These performance measures take into account a human assessment of the relevance of documents to the queries, however flawed that process is. So in the Mahesh article, there's an example early on with the Stephen King search in a database versus a search engine. He rightly points out, by retrieving a lot of book reviews and things like that that mention Stephen King, the search engine is doing what it's supposed to do, text matching. So that's what an algorithm is doing. An algorithm is simply doing what it's told to do by the system. Matching text or comparing queries to documents. Whereas when a human is making a relevance assessment and deciding whether something's relevant or not relevant, they're interested more in just the text matching. Maybe the text has to match, but more importantly, the topic of the document and the information content of the document has to match the information need. Okay, so what we see here is a graph of the relationship between recall and precision. And what this graph tells you is that if a system gets a high score on recall for a query, then the precision score is going to be low. As you can see, recall is on the y-axis and precision is on the x-axis. If the system scores high on precision, then recall is going to be low. This statistical reality actually makes sense if we talk through it. With recall, what we're saying is, I absolutely must see everything that's relevant. That means if something is potentially relevant, I want to see it so that I can make that decision. Recall is really important to people who are doing patent searches or searching for legal precedent because, for instance, nobody wants to spend $15,000 filing a patent for an invention that already exists. You want to make really, really sure that you see all previously filed patents before you file a patent that might conflict with one that already exists. You could end up either wasting your filing fee or you could end up getting sued for, huge amounts of money. Now, more commonly, people are more interested in precision than recall. That means that you don't necessarily have to read every single document in the collection that's relevant to your query. You just want to see one or two documents that are relevant, then your information need will be satisfied. However, you don't want to have to read through 25 irrelevant documents before you see those one or two relevant documents. So for you, you're asking the system to be more conservative with what it retrieves so that there's a greater likelihood that each time you click to read something actually does have to do with your query. If that means leaving out some documents that might have been relevant, that's okay. You'd rather have a tidy results set. So that describes this recall precision trade-off that we see here. In the next slide, we're going to look at two more metrics, discrimination and fallout. The next two metrics are discrimination and fallout. These two are the mathematical complements of each other, which means if you add these two ratios together for the same test, they'll sum to 1. Discrimination is the ratio of all documents that were both relevant to the query and rejected by the search engine to the number of all irrelevant documents. Discrimination tells us of all the irrelevant documents, how many were rejected. Fallout, on the other hand, is irrelevant retrieved over all irrelevant, compared to discrimination, which was irrelevant rejected over all irrelevant. Fallout asks, of all the irrelevant documents in the collection, how many were retrieved? Ideally, you want for discrimination to be high and fallout to be low, because discrimination is emphasizing the rejection of irrelevant documents, and fallout emphasizes the presence of irrelevant documents in the results set. Yuck. Okay, so here's a nice slide that just sort of sums everything up and tells us in plain English what these different things measure. Basically, recall, discrimination, and recall at N are all measures of system success, and fallout is a measure of system failure. And I apologize, I seem to have left precision off of this slide, but precision is also a measure of system success. Now, we haven't talked about recall at N yet, and it's not something you have to know intimately. It is discussed in the Mahesh white paper that you read for this week. Basically, recall at N takes into account the ranking of things by relevance. So very seldom do you see anymore a database or search engine that just retrieves things and throws them to you in a random order in a result set. Instead, they try to rank things so that the most relevant results are at the top of the list, and then the things that are less relevant are at the bottom of the list. And that keeps you from having to sift through page after page after page of results in order to see the relevant stuff. So what recall at N does is it says if the N equals 20, it says how many of the documents retrieved in the first 20 hits are relevant. How many of the documents retrieved in the first 100 hits are relevant. And what you want is the smaller the N number is, you know, whether it's 10 or 20 or 100 or 1,000, the smaller N is, the larger you would expect that recall ratio to be. You want recall to be high near the top of the list, and then it's not as important that recall be high at the bottom of the list. So even though it's called recall at N, it's closer to being a measure of precision than of recall, because what it's saying is it wants the system to put the density of results near the top of the list. So recall is the system's ability to retrieve relevant results. Discrimination is the system's ability to reject irrelevant results, and recall at N is the system's ability to rank relevant results highly. Fallout, like I said, is the mathematical complement of discrimination, and it measures the system's propensity to retrieve irrelevant results, which is bad news.